Hello, this is Richard Collins, your instructor in ATM101 Weather and Climate of Alaska here at the University of Alaska Fairbanks. Welcome to Unit 1, Observing the Sky. Today I want to highlight the fundamental ideas that we are exploring in this unit. To understand our local weather, we need to understand that our weather is not random but part of a larger weather system. A major event like a blizzard is part of a weather system that has a characteristic pattern. We see these patterns in pictures and images taken from satellites. In satellite images, we see that clouds are not randomly scattered across the globe, but are organized. Clouds appear in swirling and curved patterns. Clouds are thicker in the tropics. Individual storms are clearly visible, like Hurricane David off the coast of South America. Satellites allow us to see these weather patterns and understand the weather systems on a global scale. What are the basic characteristics of the weather and the atmosphere? We observe and measure the weather using the following techniques: sky watching, weather stations, satellite measurements, weather radar, weather maps and charts. We understand much of the weather using the ideas of high and low pressure systems, warm and cold fronts. Our measurements and understanding are linked. How we choose to make measurements is driven by what we are hoping to understand. When we look at the sky, we usually are drawn to the clouds, which move and change their shapes. The shape of clouds is associated with the weather associated with the clouds. Fluffy clouds that extend high in the sky are associated with severe rain and thunderstorms. Clouds at different altitude levels often move in different directions as the wind direction varies with altitude or height. Rainbows are formed by the sun shining on water droplets and being refracted and reflected. In Alaska, we see halos and sundogs that are formed as sunlight is refracted by ice crystals. Weather stations make formal meteorological measurements continually, day and night, through the year. These stations provide measurements of surface conditions as well as cloudiness. Radiosondes are attached to weather balloons and launched at some weather stations. Radiosondes provide meteorological measurements up to heights of about 20 miles or 32 kilometers. Radiosonde measurements are critical for understanding the weather and climate. And in fact, students in ATM 101 have helped launch radiosondes in past semesters. Satellites have revolutionized how we study weather and climate. By looking at sunlight and heat, we can determine temperatures, cloud properties, and the distribution of water. In the visible cloud images in the upper left, we see the clouds appear bright white, reflecting sunlight. In the infrared thermal image in the upper right, we see that darker regions are warmer and brighter regions are colder. In the infrared water vapor image in the lower left, darker regions are drier and brighter regions are wetter. Putting the three images together, we look at the cloud band across the eastern United States. We see in the visible image that there are clouds extending along the length of the United States on the east coast. In the thermal infrared image, we see that these cloud tops are cold, which indicates that the clouds are thick and extend high in the atmosphere. And in the infrared water vapor image, we see that these clouds are bright and therefore full of moisture. So by combining the three different types of images, we can get a deeper understanding of the character of the clouds. While satellites can show us where the air is humid, weather radars can show us where it is actually raining or snowing. Radio waves are transmitted by the radar and reflected by falling water droplets. The strength of the echo increases as the amount of rain falling in the cloud increases. We see a band of precipitation across the lower 48 with stronger rainfall in the south. Radar in Anchorage provides a view of the entire Cook Inlet region. Rainfall can be very patchy and the radar captures the pattern of rain across a broad area. We represent the state of the weather on weather maps. Weather maps show distributions of pressure highlighting the presence of high and low pressure systems. The maps also show cloudiness indicated by shading and precipitation indicated by symbols. Pressure contours are plotted as thin lines, like the contours on a geographic map. Fronts are plotted as thick lines on the map where bodies of cold and warm air meet. This semester we will see that the way that we map weather reflects how we understand weather processes and systems. When meteorologists look at a high-pressure or low-pressure system, they associate a pattern of weather with that system based on how they understand the system works. Wind blows outward from a high-pressure system and inward to a low-pressure system, just as shown in the diagrams on this slide. Where does the air come from that blows outward from the high-pressure system? It comes down from above. The downward moving air results in clear skies that gives warmer days and cooler nights, and this is the weather we associate with high-pressure systems. Where does the air go that flows into the center of a low-pressure system? It goes upward. The upward moving air results in clouding skies that give cooler days and warmer nights and often can give precipitation, and this is the weather we associate with low-pressure systems and associate with storms. Fronts are the funny lines on weather charts that mark where different large bodies of air, called air masses, meet. Air masses have different properties. For example, an air mass that has dry and cold air is heavier than an air mass that is warmer and more humid. When air masses collide, they push each other with the lighter or less dense air tending to rise over the heavier and more dense air. When air moves upward, it leads to cloud formation and precipitation, so weather tends to follow fronts, and this is why we plot them on weather maps. Different weather forms along fronts with different characteristics. For example, snow is more likely to form at a warm front than a cold front, because air that is warmer tends to have more moisture in it than air that is colder. As we are sky watching this semester, we will be drawn to light and color in the sky. Sunlight interacts with gases, droplets, and ice crystals in the atmosphere. The moon has no atmosphere and so has a dark daytime sky as shown in the photo in the lower left. The sun appears white in a black sky. On Earth, the rays of sunlight hit the gas molecules in the atmosphere and are scattered. The sunlight is scattered in all directions, some continuing in the original direction and some now traveling in other directions. Thus, the sunlight ricochets around the sky like a cartoon bullet. Gas molecules scatter blue light more strongly than red light, so the blue light scatters through the atmosphere and gives us the daytime blue sky. The red and orange light travels more directly with less scattering, and so the sun appears yellowish in the sky. The sun appears redder at sunset when sunlight travels a longer path through the atmosphere, losing its blue light and directly sending the red light toward our eye. Water droplets and ice crystals also interact with the sunlight. These interactions give us the white clouds that we see in the sky. The droplets and crystals can also act as lenses and prisms to create rainbows, halos, and sundogs. Light is refracted or bent by water droplets and ice crystals in systematic ways. Light bends differently in ice crystals of different shapes. Clouds of ice crystals with columns and plates will create different arcs, rings, and colored spots in the sky. In the photo on the left, we see a spectacular display of multiple arcs, sundogs, and halos in Fairbanks. In halos, the ring that is created stretches 22 degrees outward from the sun due to the fact that hexagonal plate ice crystals bend or refract the rays of sunlight by 22 degrees, as shown schematically in the diagram in the upper right. To get a strong halo or ice dog display, we need to have the ice crystals all oriented in the same way, falling as flat pancakes. Thus, these phenomena form best in calm conditions with low winds, and these are the kind of conditions we often get in Fairbanks in the winter. The refraction also separates different colors. Red light is bent slightly different in ice crystals and water than blue light, and so this is how we get the banding in different colors, the rainbow effect, or the effect associated with sundogs as shown in the pictures on the lower left, where we separately show the left sundog and the right sundog as seen in Fairbanks in January 2017. The appearance of a halo around the moon can indicate the presence of cirrus clouds and be used in forecasting. Cirrus clouds often precede a weather front, and so the appearance of a halo can be used to forecast a change in weather the next day. Final thoughts for this unit. Weather is the state of the atmosphere at a given place and a given time, and is described by temperature, pressure, wind speed and direction, humidity, precipitation, visibility, and cloud cover. Climate is the average weather, or prevailing pattern of weather over several years. In one way you can think about when you travel, you plan for climate, but when you get there you actually experience the weather. Describing and understanding the weather can require observations from local, regional, and global viewpoints. No single view of the weather is sufficient to forecast the weather completely. Understanding weather observations and forecasting weather requires that you use a physical model to interpret the observations, and increasingly our physical models are represented by computer weather models. Weather information is complicated, and human insight is still critical in making sense of it all. The impact of severe weather on our lives has largely decreased due to improvements in forecasting that gives us more time to prepare for it. And in the image on the right, I just want to highlight some of this in terms of combined radar and satellite images provide information on where weather is most active or severe. As we said earlier, the satellites provide the view of where the clouds and moisture are. It's the radar that identifies where the precipitation is, which can be the most severe element of the weather. Thank you for your attention.